Hello everyone, my name is Joshua Jimmy Tama, and today I'll be talking about two very important building blocks in digital logic: multiplexers and adders. These components are essential in designing efficient digital systems, and by the end of this presentation, you will understand how they work and where they are used. Here's what we'll cover in this presentation. We will start with an introduction to multiplexers, then look at their types and where they are applied. After that, we will move on to others, their types and applications. Finally, I'll give a quick summary of the key points. Now let's move on to what a multiplexer is. A multiplexer, often called a MUX, which is MUX, is a digital circuit that selects one input from many and sends it to a single output line. It's also known as a data selector. Basically, it helps decide which input data should go through. Now, let's move on to how multiplexers work. Here's how a multiplexer works. It has three main parts: data input, select line, and one output. The select line are what determine which input is passed to the output. For example, if you have two select lines, the multiplexer can choose from four different inputs because 2 to the power of 2 is 4. Now let's move on to multiplexer applications. Multiplexer Multiplexers are widely used in digital systems. For instance, they route data from different sources to a single destination. In memory addressing, they help select specific memory locations. And in communication systems, they allow multiple signals to be transmitted over a single channel. Now that we are done with multiplexers, I'm going to move on to what is an adder. Now let's talk about adders. An adder is a digital circuit that performs binary addition. It's a key part of what's called the arithmetic logic unit, or ALU, in processors. Basically, it helps computers do math. Now, the types of adders. There are different types of adders depending on what you need. A half adder adds two single binary digits and gives a sum and carry output. A full adder can add three binary digits, two inputs, and a carry in. For adding large numbers, we use a ripple carry adder, which connects multiple full adders in a sequence. Now let's move on to other applications. Adders are everywhere in digital electronics. They are part of ALUs inside processors. They are used in digital counters that track values, and they are also used in calculators whether basic or complex, to perform arithmetic operations. So how do multiplexers and adders compare? Multiplexers are used for selecting and routing data. They output one line from many inputs using control signals. Adders, on the other hand, perform arithmetic operations. They give sum and carry output and are crucial for computation. Now, as you all can see, this is a 1-bit arithmetic logic unit diagram with a multiplexer and an adder. Now, let's look at the key takeaways from this presentation. To wrap it up, multiplexes are used to select to wrap it up, multiplexes are used to select and route data, while others perform arithmetic operation. Both are essential for building efficient and smart digital systems. Without them, modern electronics wouldn't function the way they do. Thank you for your attention. I hope you now have a clear understanding of what multiplexes and others are and why they are so important in computer architecture.